think that is an important aspect in research. So yes, it is. So sample size determination, let's proceed. So see, so far what you have seen, or you have heard about the research question, and they said that once you have identified right research question, half of the research is done. Very right? Then you also just now heard that same research question can be answered using any of the board study designs. I mean, you'll be hearing clinical trial, right? But 3 study designs which have been told, you can take the same question and you can use any of the study design, right? It's like something, if I have to go from here to Chandigarh, I have different options. I can take bus, I can drive, I can go by train, I can go by air. So these are the study designs. And what you choose depends on your constraints, right? And the moment I choose to go by train, then I have to follow I have to go to railway station, not to airport. So I have to follow all the rules and regulations of that study design, right? Maybe sample size calculation, maybe analysis, maybe the way you make table, everything you have to follow for that particular design, what you have selected, right? And then you go as per that. So that is what? Research question. Your research question is always correct, not for the sample that you're doing. Always for a defined target market. Whatever may be your research question, it is always defined or stated in terms of target population, not in my sample. But you will never have luxury to collect data or to study entire population. You will always be dealing with sample, right? You will never have, so you identify how much, so then the question comes sample size, right? Because how much I should study, right? And the second part is, having identified or having determined these many, how should I go about enrolling these many in my study? That is sampling part. So the session is on sample size and sample. So sample size is an issue when, see, there is a process in research: design, conduct, analysis, interpretation, dissemination. So this is an issue at design stage. And also this is an issue at interpretation stage. Like if you're reading somebody's paper and before you accept his finding, you definitely like to know whether the sample size that he has taken in his study, is it adequate enough or not, right? So it is at both the stages. Now you saw 3 study designs, right? And he also mentioned about hierarchy of evidence, right? So lowest was what? Expert's opinion. Then comes your case report, case theory, and then comes cross-sectional, case control, cohort, clinical trial. So these are planned studies, right? So you need sample size calculation for these 4. And above that, you have systematic review and meta-analysis. So sample size calculation is an issue for these middle ones: cross-sectional, case control, cohort, and clinical trial. And he also said about why clinical trial is put it on the top. Whole thing depends on quality of data, right? Quality of data determines the quality of evidence that you get from the study. Just now you heard case control study, and you also heard about nested case control study, right? Case control study, he said, you enroll based on the outcome, and you are measuring past exposure, which somebody is telling from the recall. And nested case control, he said, that is built within a cohort study, right? So within a big cohort study, that is nested case control study. So in case control, you have outcome data, you have exposure data, which is coming from recall. In nested case control, both outcome and exposure, investigator himself is collecting. So there is less scope of error, right? So therefore, the quality of data, quality of evidence, where it will be better, case control or nested case control? Nested case. The whole thing boils down to quality of data. That is what determines the level of evidence. So whatever we will study design, so you saw observational studies, experimental is coming, right? So observational studies, 3, cross-sectional, case control, cohort, right? So for these 3 studies, your research question must be for the real population. When I say real population, means living in the geographical area. Maybe South Delhi, maybe Delhi, maybe North Delhi, or North India, whatever. So there is a real population, right? And your question is for that real population. And from that population, you draw a sample, right? That is observational study. But when you come to clinical trial, there is no real population. You are doing a study in clinical trial in hospital, sitting with list of inclusion and exclusion criteria. Whoever comes to your hospital gives consent, and fits in inclusion exclusion, gives consent, gets into your study. So all patients coming to aim, they are not representative of all such patients in the population. This is sample of convenience. This is sample of convenience. That is random sample, right? And all the statistical methods that we use, it requires assumption of random sample. So if you are doing clinical trial, you will be told, when you are doing clinical trial, whatever study you are doing on sample, but the results that you get from sample has to be extrapolated to target population. So this is the sample of convenience. So what is your target population for intervention study? It is a hypothetical population, not the real population living in. If you have done a study on stage 3 patients, male, this, that, all that, in a sitting in hospital, then your results will be applicable to all such patients wherever they are. Not necessarily North Delhi, South Delhi, wherever they are. Right? Okay, so that is basically, but whatever may be your study design, whatever may be your question, sample size would definitely be an issue. Right? So what I would like you to understand is that for your research question, what inputs are required for sample size calculation? You don't need formula. I don't need formula. Nobody uses formula, right? But definitely you need to know that for my question, what inputs are required for sample size calculation. So once you know that, then rest is fine. Right? So that is what I would definitely, for the sake of completeness, I'll show you some formulas, some calculations, some examples, but that you can ignore. Or I will leave the slides, you can read it whenever you get time. But that is not important. Important thing is to understand that for my research question, what inputs are required for sample size calculation. So those are the, we'll discuss those things. Now studies are of two types. One is qualitative, second is quantitative. For qualitative studies, you know what is qualitative studies. So for qualitative studies, there is no formal way of calculating sample size. Whereas for quantitative studies, there are formal ways of calculating sample size. Right? Qualitative studies, you don't calculate sample size, but still there is some indirect way of doing that. From how many I should collect data. They go on doing till the point comes that they call it saturation point. Beyond which they don't get any new information. So what is the point of talking to more people? Right? So that is basically saturation point, but there is no formula. It depends on question and depends on the context. Whereas for quantitative, yes, there is formal way of calculating sample size. So in quantitative studies, again, there are two kinds of studies. One is exploratory, second is confirmatory. Right? You heard, they said for some question sample size, they said, no, you need some expected results. Right? So that means if you're doing an exploratory study, that means you're doing this study for the first time. So you have absolutely no prior data existing. You have no limited evidence existing. Right? So this is being done for the first time.
Hello, is this mic is clear? Are you getting better voice with mic?
No problem with this?
Yes.
Am I audible?
Yes.
Okay. Audible? Okay. So basically,
somebody can sit to the left of the move the slides. So sir can speak in the mic.
exploratory studies are those which are being done for the first time. Right? So somebody who is doing a study, he comes to me for sample size calculation. So for samples, so knowing that how many participants I should, he has not done his homework. Right? So I asked him that, can you tell me what is the kind of anticipated result or what kind of result you are expecting? Then he said, this is a stupid question. That's what I want to know. So when he says, "Chho, Why? He says that no, nothing is available. He puts the ball in my court. He says nothing is available. Right? Then I tell him, then you please go back and do a pilot study. And with that result, you bring it, and then I will do the calculation. So next day he comes and he says, sir, there are 10 studies available. He wanted to do prevalence study. So there are 10 studies available. So, but results are ranging from maybe 20% to 60%. Right? So I will take that 20%. Rarer the outcome, larger will be the sample size. Is sample size always an issue? Not always an issue. Right? When it will be an issue, it will be an issue when there is a variability. When there is no variability, where is the issue? Where is the question of sample size? Right? If your question is, Hawaii Jahaj mein 20,000 kilometers say, if I throw, what will happen to individual? How many of them they will survive? इसमें कोई variability है क्या? Everybody will die. So where is the question of, there is no variability, and research deals with variability. If there is no variability, no scope for research, right? For example, if you are doing study in females, and so would you have a question on gender in your questionnaire? That's constant, so it's not, isn't it? So research deals with variability. No variability, no sample size. Less variability, less sample size. More variability, more sample size. It's all question of variability, and you need to capture the variability. So exploratory studies being done for the first time, no idea about and all that. So sample size is usually done on feasibility, basically, right? Confirmatory studies are those where limited data is available, limited evidence is available. You want to either confirm or refute that limited evidence. That becomes your anticipated guess. That becomes your anticipated guess, and you take that and you calculate your sample size. So sample size is calculated using anticipated or expected results, right? Based on your prior studies or all the statistical inputs are there. So basically, to calculate sample size in any given situation, two kinds of inputs will be required. Two kinds of inputs will be required. One, statistical errors, right? And second, anticipated results. That's all. Next, please. Now, sample size, as I told you, is an issue at two stages. One is design stage, second is at interpretation stage. Design stage, you would like to know. So if I'm evaluating your proposal, definitely I would like to know that how many participants or how many subjects you are going to take, right? If I'm reading your paper, definitely I would like to, before I accept your results, I would like to see, is it coming from adequate number of subjects or not? Right, so this is an issue at both the stages. Next, please. Often, no formal sample size calculation is done. Many papers you see, they don't do sample size calculation, and they say the number of participants I will take, and during 1 year time, whatever I get, I will enroll. Or maybe I have budget for 4 kids, and from these 4 kids, whatever sample I'm able to do, that is my study size. So sample size is never determined based on your convenience or your constraints. So sample size and analysis both are linked together. Sample size is basically reverse of data analysis. To do data analysis, there is some, just imagine there is some formula. That formula has been reapproximated and simplified, that becomes your sample size formula, right? So if you have done your study and you bring your data to me for analysis, I will ask you, can you tell me how did you calculate your sample size? Because same analysis I will do, right? So sample size calculation inputs are anticipated results. And at the end of study, you will see whatever you had anticipated. Did you get that or not? Or how close or away you are from your anticipated results, right? You're not going to do anything else. Next, please. There are implications of small sample size as well as large sample size. What happens when your sample size is too small? Most studies, they don't do sample size calculation, small sample size. And because of small sample size, what happens? They miss the effect. They are not able to detect the effect that year, right? So if you're comparing something in two groups and you have taken small number, your sample size is small, and because of small numbers, you are unable to detect any difference. You are unable to detect any difference, and you say there is no difference. absence of proof is not proof of absence. If you have not been able to detect something, it does not mean it's not there, right? Because your study had inadequate number. That is what most of the people basically do that. That is false negative. That is false negative finding. On the contrary, and what they do is they know that when they submit for publication, somebody will ask sample size. So they say this, a pilot study. Because once they're at pilot study, then nobody can ask question on samples. Don't you see this is a pilot study? That is misuse of word pilot study. There's nothing like pilot study. There are only two kinds of studies, one with adequate sample size and others with inadequate sample size, right? Pilot studies are basically feasibility studies, right? So before you do your main study, you do a pilot study. Before you go for your main drama, you do a rehearsal so that you could correct your all those steps and techniques and dialogues or whatever. You cannot draw conclusions from your pilot study. There's no audience for pilot study, right? So, but this is a highly misused word. See, many published pilot studies. When pilot studies are only for, before you do that. Next, please. What happens when n is too large? With large numbers, you can prove anything. With large numbers, you can show, you will do some statistical analysis and you will say highly significant and you will show anything. There was study. Say, for example, if you use NFHS data, very large data set, and you get odds ratio 1.1, highly significant. What is the point? Isn't it? Statistically, you see difference, but 1.1, does it make any sense? On the contrary, you have small study size, you get odds ratios 2.0, but because of small sample size, not. So clinical significance and statistical significance that you have to keep in mind, right? So large sample size, there are problems on the other side. And also, there is inverse relationship between volume of data and quality of data. More data, poor will be the quality, given the same resources, right? And also, if you're doing large, taking too many samples than required, you're wasting resources. Your finding will come later than when it should have come, right? So that also is unethical part. So that is why you need adequate sample size. Yes, please. Yeah. So then, whatever may be your research question, whatever may be your study design, at the end of study, you will provide a study result, isn't it? At the end of the study, for every research question, you will provide a study result. And two questions will be asked for every study result. They will ask you, okay, your question was for target population. You have done a study on sample. And then you are saying that on sample, I got this, and you are extrapolating to target population. Tell me how accurate or how close or how valued your reported results are to the true fixed unknown result in the population. In the target population, there is an answer for your question. There is an answer for your question, nobody knows it. If anyone knew, why will you do the study? So they will evaluate your result, how close it is to the true fixed unknown result in the population in the absence of that. How do they do that? With a method section. With your method section. And second thing they will say, but you have done a study only on one sample. How sure you are that if you repeat the study under the same protocol, you are going to get the same result? Are your results reproducible? Isn't it? So they would like to know the reliability of your results. And what is the priority in research? Validity or reliability? What is the priority in, you'd like to have your results both valid and reliable. What is the priority in research? Validity or reliability? Validity, right? Say suppose you have two friends, A and B. A borrowed 100 rupees from you 5 times, never returned. B also borrowed 100 rupees from you 5 times, sometimes returned, sometimes did not return. Who is more reliable? A is more reliable. Give him 6th time. Give him 6th time. You can predict what is going to happen. Would you like to give next 6th time to A? You can predict. He is very reliable, right? So validity is the function of conduct of conduct of study or method section. Pay attention to your method section, right? That means selection, measurement, analysis. that will determine, so they threaten the validity of study result. Sample size threatens the reliability. For example, I have huge population and I say forget about sample size. I will study entire population, but I will study in wrong manner. I study entire population in wrong manner. Will my results be valid? Not valid. Away from the truth, not valid. And if I study the same large population in the same wrong manner, number of times, every time I get the same result. So absolutely reliable. Right? Absolutely reproducible. So reliability is for the valid result. Right? So first thing in research is we would like to measure or we would like to capture what we want to capture. And that we would like to capture more precisely. Every time we should. So that is what it is. So that is what is basically reliability. Sample size is the issue that is addressed for reliability. Right? So we are here, we are addressing what? Validity or reliability? We are here to address reliability part. Right? Okay. Next, please. Now, there are two approaches for sample size calculation. One is precision based, second is hypothesis based. Right? Precision is what? They also mentioned, so somebody mentioned. So precision means that range of results. I will come to example, then you will understand this. Precision means how precisely you want to measure your result. More precise you want, more price you have to pay. Isn't it? Suppose you want to buy a shirt and you say, मेरा collar का measurement ऐसा होना चाहिए, इतना होना चाहिए, वो ऐसा होना चाहिए, so precise, then you have to pay heavily. But if you say, no, I am not precise, तो थोड़ा ये भी थोड़ा बड़ा हो, थोड़ा छोटा हो, थोड़ा, you can get in sales cheaper. Right? So how precise you are, more precise you are, you have to pay more price. If you say, no, I want exact thing, no precision, then you study entire population. You study entire population, there is no question of precision, right? Precision means range of results. Precision means range of results. So there are two ways. One is precision based, second is hypothesis based. Hypothesis based is usually what we do is precision based. Next, please. So there are two kinds of precision. One is relative precision, second is absolute precision. So just please understand this. Relative precision is, suppose somebody wants to estimate something, that what percentage of people they adhere to this practice, some practice, right? That's what he wants to estimate. He comes to me for that, what should be my sample size? So then I ask him that, can you tell me, do you have any guess as to what would be the kind of result in the population? So he says, I think 50%. 50%. But are you sure it will be 50%? No. I'm not 100% sure. So can you tell me that some range of your, then he says, I'm 95% sure that it is 10% around 50%. That means he says, I'm 95% sure that the true prevalence in the population would be somewhere between 40 to 60%. So he's saying 50% and plus minus 10%. So that 10% he's saying is basically absolute here. But there he says 10%. So 50%, 10%. How much is 10% of 50%? 5%. So that 5% is relative. But the second person he comes, he says in absolute terms. He says in absolute terms, 10%, that means 40 to 60%. In relative terms, 45 to 55%. So this 10% in absolute, it would be how much in relative terms? How much 10% is of 50%? 20%. So 20% would be, so think in relative terms, but put your value in absolute terms. So that is the kind of thing. So these are two things, but relative and precision, absolute. Next, please. Anticipated versus observed precision and power. So many times I have seen in papers when they have a paragraph on sample size, and in the sample size, their anticipated results, what they write, which they have anticipated results which they have used for sample size calculation, is exactly same as what they got in the study. That means they recreated this paragraph. You will never
your anticipated results and obtained results will never be the same. Will never be the same. You never get what you anticipate, right? So it will never be the same. So I mean, so it is when you calculate the sample size at the beginning, you assume some power, and at the end, then you calculate power that whatever you had assumed, how close you are. Then power equation changes. Power equation changes. So that is what it is next. Now, to know sample size calculation, these are the 5 things that you need to know. Right? If you want to understand sample size, these are the things that you need to know. What? Number 1, type of variable. Type of variable, right? And type of variable from statistical point of view. How many types of variables are there? Only 3, no 4th. Only 3. Categorical, quantitative, and time to event. There is no 4th variable. Only 3 from statistical, from analysis point of view, right? And from epidemiological point of view, how many variables? Again, 3 variables. Outcome variable, exposure variable, and other factors. There is no fourth variable. That is from functional relationship, and this is from measurement point of view. So you need to know what is categorical variable. So categorical variable could be yes, no, could be multi-categorical, could be ordinal. So you need to know what is categorical. Quantitative, you know what is quantitative. Birth weight of newborn, systolic blood pressure. So these are quantitative. Time to event is combination of both. So time to event is a variable where you assign importance to the time at which event occurs. Like two deaths, one occurs at 6 months, second occurs at 2 years. Both are deaths, but they are not same deaths. So when you assign importance to the time at which event occurs, that is time to an event. Then second thing that you need to know is the study design that you have already covered. Study design you already know, right? Next you need to know is the summary measure. And those are the things that you're going to calculate at the end. That will depend on your research question. So and then statistical error. So this 4th and 5th, even if you don't know, I mean, doesn't matter much. 4th one, of course, you need to know. 5th one doesn't matter much because those are alpha, beta. There are 3 values, only 3 values. And of the 3 values, sometimes you use 1, sometimes you use 2. That's all. We'll see what are those values. Next, please. So sample size that you calculate in your protocol, you mention in protocol is not a rule. It is only a guideline. Why it's a guideline? Because the formula that you're using for sample size calculation is approximated, simplified. And in that simplified, whatever inputs that you're giving are your guess estimates coming from some pilot study or small studies, right? So when your formula is approximate, inputs are such guess estimates, how can the calculated number be a rule? It is only a guideline. So if you have calculated your sample size 100 and you have been able to enroll only 90, nothing will fall down, right? There is no problem. Or also you calculated 100, but you were able to enroll 120, still 120 could be less because what you had anticipated was on higher side. What you had anticipated was on higher side. You will rarely see a study where what you get is more than what you had anticipated. Because when we anticipate, हम थोड़े बढ़ा के देखते हैं, isn't it? Most of the time, like exams also, when we calculate mark, तो बढ़ा के, so right, so you never get that case. So always it will be. So it's basically these are guidelines, not basically exact. You had calculated 100, but you enrolled 90, so throw it. No. Right. Next, please. There are 3 ways to get sample size. There are 3 ways to get sample size for any situation. One is there are simple formulae, 8th, 9th class तक के formulae हैं, so that you can use. If you don't like formulae, right, then there are ready-made tables available for most situations. Ready-made tables available for most situations. If you don't want to do that, there are programs available. But whatever you do, you definitely need to know what inputs are required for this question. That is what we'll discuss now. Right? There are 3 ways. So hereafter, what we'll do is we'll take research questions, and for that question, 3 slides. One is what inputs are required. Second is example. Taking that example, do the calculation and get the number. And third is for the same example, see the table. Are you getting same number or not? We will see 3 slides for several set of examples, right? And I will leave all these slides with you, which you can read later. Next, please. Now, as far as I told you, for sample size calculation, 2 kinds of inputs are required. One is statistical, second is anticipated results. The statistical are basically errors, because whatever study you do, you will never get 100% correct. None of your diagnostic methods are having 100% sensitivity and specificity. None of the responses that you get, you can take it for granted that 100% correct. There would be error. So upfront you assume that there will be this much amount of error. Those are the statistical errors, right? And you heard there are 2 kinds of studies, descriptive and what? Analytic. Descriptive studies, repeatedly they say there's no comparison group. So if you're calculating sample size for descriptive study, there's no comparison group. Descriptive study only precision. Analytic study, power. Analytic studies, comparison group. So there is a power. So for analytic studies, power will be used. Either 80% power or 90% power. Descriptive study, only that will be used. So for descriptive study, only alpha will be used, 0.05. Analytic study, in addition to alpha, one of these 2 numbers will be used, right? And sample size calculation is never done only once. Sample size calculation is like shopping, right? When we go for shopping, most of us don't go to enter into one shop, pick up and go. We know that this is what is my budget. So all of us, we have our resources. All of us, we know what is the time limit, what is the budget and all that, given that we want to maximize. So do multiple sample size calculation and settle for the one which is feasible for you and which is technically acceptable, right? So settle for that, but you have to do set of calculations, not one. Next, please. Now, these are inputs required for sample size calculation, anticipated outcomes, or if you're doing case control, then anticipated exposure, then precision or hypothesized value, statistical errors, power. Power would be, of course, only for analytic studies, anticipated non-response. So sample size that you calculate are basically evaluable numbers, right? Are evaluable numbers, not numbers that you enroll. Suppose you're doing a prevalence study, you calculated number as 100, but you know that 10% of them, they will not respond to my question. So you better enroll 110, so that even after 10% non-response, you get what you had calculated. If you're doing a follow-up study, 20% dropout, so have that cushion of 20%, so that even after dropout, you get, right? So these are basically evaluable numbers. Method of all that sampling design, method of randomization, modified alpha value. Again, see, nobody does that modified alpha value. You have 2 objectives. You're doing a clinical trial, you have 2 objectives. And how are you going to decide which one is better? Is it that any one of the 2? That is multiplicity. Many times you see they have 2 groups and they're measuring outcome, not at one time point, 30 days, 60 days, 90 days, repeated. And you're analyzing a different time point. When are you going to declare what is your primary outcome? What time? So multiplicity, all those things are there. So these things have to be taken into account in your sample size calculation. Next, please. Now, how many research questions are there in health sciences? There are different levels of researchers, PG students, right? PhD students, MD, MS, DN, research students, and faculty members. Then faculty members who do collaborative research. There are different levels of researchers, so many departments, disciplines. So how many possible research questions? And somebody also said that sample size is calculated for what? Primary or secondary? Primary, isn't it? Sample size calculated for primary. If you have 2 primary objectives, then you do sample size calculation for both of them. And the one giving larger sample size becomes your study size. So how many possible research questions in health sciences? Finite or infinite? Finite, only these questions, no other question. If you find any other question, please add to this list. No other question in health sciences. Your words may be different, but it has to fit into these, right? And if these are your primary research question, then sample size calculation has to be done. right? So let us see for each of the primary, I'll leave the slides, you can just, it will be shared. So these are the questions, right? So prevalence of a condition, that could be a primary objective. I want to know prevalence of, my primary objective is to know prevalence of diabetes. My secondary objective is to know the risk factors for diabetes, to generate hypotheses, which I can later test with analytic studies. So to do prevalence study, what inputs are required? That's what you need to know. My primary objective is to estimate mean fasting blood sugar, right? That is quantitative. My primary objective is to know correlation between two quantitative parameters, correlation coefficient. Third question. My fourth objective is I want to measure agreement between two methods or two raters. Agreement. Agreement is always between at least two at the same level. Both same condition is applicable for both. Like owner and tenant, उनके बीच में agreement होता है. Same conditions are applicable. 3 months notice is applicable. जो भी कुछ है, right? Or 1 month, whatever. So that is agreement at same level. Next is diagnostic test. उसमें different होता है. One is gold standard, other one is candidate. Gold standard is always at the higher level, right? And you want to know how good my candidate test is with reference to gold standard, sensitivity, specificity, right? So you have 4, like 1, 2, 3, 4, 5. If your question is any one of these 5, study design is cross-sectional, right? Primary objective. Your next, so you need to know what inputs are required for these objectives. Then if your question is, what is an incidence of an outcome? What are the predictors of an outcome? What is study design? You heard study design? Cohort study, right? What is the etiology of an outcome? Risk factors for an outcome. What study design? Case control. And last one is evaluation of candidate intervention, right? These are only 9 questions. I have not seen, maybe, or I can say, to be on the safer side, these are the most commonly asked questions, to be on the safer side, but I have not seen. I tried. There is no other question. There is no other question. And if these questions are your primary objective, then what inputs you require for sample size calculation? Your inputs are expected results, right? So now let's take this as the last slide, and to prevalence of condition. At the end of study, what would you calculate? Prevalence of condition, isn't it? That is what is. So when you calculate the sample size, you need to tell me the anticipated prevalence. And then you also need to tell me the range in which you think that the prevalence would lie, right? So if you said 50%, then you say actually 40 to 60%. So 10% is your precision. That 10%, that means 10% plus, 10% minus. That 10% precision that you're mentioning is nothing but half of the confidence interval, isn't it? That is nothing but half of your confidence interval, half of the width of the confidence interval. And wider the precision better or narrower the precision better? Narrower is better, isn't it? When will you have no precision? Study entire population, isn't it? So you will always have some level of precision. Mean of a characteristics, what inputs are required? You need mean, you need standard deviation, isn't it? So you need precision in the mean. You need precision in the mean. Next is correlation coefficient. You need anticipated correlation. What about agreement? You need expected agreement, and of course precision. Then diagnostic test. What is the study design for diagnostic test? Diagnostic test, you have one group as disease, other group as non-disease, and in both of them you are applying your candidate test to know sensitivity and specificity. So what is this design? Is it cross-sectional or case control? Cross-sectional or case control?
It can be case control also.
It will not be case. In case control, you are comparing case exposure among cases with reference to control. And in diagnostic test study, you're not comparing one side is disease, other side is non-disease. From disease side, you get sensitivity. From non-disease side, you get specificity. You never compare sensitivity and specificity. So these are two prevalence studies. So the sample size that you calculate for diagnostic test study, you have to do two sample size calculations. One, to know how many disease I required, and second, how many non-disease I required. The word control does not exist in diagnostic test studies. The word control, meaning of control is comparator. The word control does not exist in diagnostic test study. That is why it's not an analytic study, it's a descriptive study. And you will calculate sample size as you do for prevalence. What is incidence of an outcome? You need to know incidence, you need to know precision. What are the predictors of an outcome? We said that for predictors, cohort study, what summary measure you use? Odds ratio, risk ratio. You use risk ratio, right? And he also said that for case control, you use odds ratio. So you need to know anticipated odds ratio and the precision. You need to know anticipated risk ratio and the precision. And when you come to intervention, then you need to know estimated effect size. Anticipated expected effect size, that means difference in outcome rate between the intervention and the control arm. So those are the inputs that are required for sample size calculation. Next, please. Now you can see, you can take examples. You can take just examples. Say, for example, cross-sectional study. So there will be some formula 4PQ upon D square. 4PQ upon D square is applicable only for prevalence and diagnostic test studies. Nothing else, nowhere else. Right? So P is anticipated. Go to next, please. This is an example. So he says, I think prevalence is 20%. And then he says, please, I think I'm 95% confident that the true prevalence in the population would be somewhere between 15 to 25%. That means 5% around 20%. Right? So that I will take it as D and calculate the sample size, which is 245. Suppose this formula is, this calculation is too much for me. This is too heavy for me. So I'll go to the table, next table. Go to the table, next one. And then here you get 246, around same number. Around same number you get. See, column is anticipated prevalence, row is precision. So 20% and your 5%, 246 you get. Right? So you get almost the same number if you don't want to calculate. Or if you want to go to AP Info or all those programs are there, Open AP or NMaster or NAdvisor, any online, there are so many online sample size calculators. You use any one of them, you get almost the same number. Next, please. Now for quantitative, again, there is some formula. Next, so I think I will not discuss this. Next. So this is the example. For this, actually, there is no table. Next. For correlation studies, there is some formula. Go to next, please. There is an example. Use this formula, calculate this, you get 211. If you don't like this calculation, go to the table. Same thing, go to the table. Here you get 211. Next. There you get 211. Right? So there is no need for you to remember the formula, no need for you to calculate it, but you definitely need to know what inputs are required. What inputs are required for my sample size calculation. Next. Now, when you go for diagnostic test study, again, you have two prevalence. So go back to some do things like teacher, back, please, back. Yeah, here, next. Yeah, hold on. Now, same table you use for diagnostic test study. Suppose if somebody is doing a diagnostic test study and he wants to know how many disease I should take, how many non-disease. So I will ask him, can you tell me anticipated sensitivity? He says 90%. And what is the precision? He says plus minus 5. So I'll go to 90%, 0.9 there and plus minus 5 here. So I get some 138 to something. So that many disease I require. Then about the specificity. So I'll ask me what about specificity? I think 80% and plus minus 10. So I'll go to 0.8 and this 0.1, that will tell me how many non-disease are required. Right? So I will do two calculations for diagnostic test studies using same prevalence table. Next, please. Now for case control studies, next. Yeah. Next. So for case control studies, you will use odds ratio. For cohort studies, you will use risk ratio. I hope you understand the difference between odds ratio and risk ratio, right? So odds, so just take this example. Now treat this, that circle as 4, right? Black one is 1/4, white one is 3. Black one is 1 and 3 is, and white one is 3. So what is the probability of being disease will be 1/4, isn't it? What is probability of disease? 1/4. What is probability of no disease? 3/4. And the ratio of the two is odds. So when you take the ratio to 4 cancels, so you get 1/3. So odds is nothing but ratio of two probabilities, event happening, event not happening. That is odds. And if this odds, if you see among the smokers, so that is odds among exposed. And same thing if you see among non-smokers, that is odds among non-smokers. And the ratio of the two is odds ratio. Right? Ratio of the two is odds ratio. So next table. So you can see here, see 2/2 table will always follow you. So get used to this 2/2 table as quickly as possible. So in this 2/2 table, what is the total N? 200. Very quickly, let us see. In this table, how many are exposed total? 100 are exposed. How many are unexposed? How many have disease? And how many do not have disease? What is prevalence of disease in the sample? 80/200. All right, isn't it? What is the probability or risk of disease among exposed E plus? 60/100, right? What is the risk or probability of disease among unexposed? 20/100, isn't it? Isn't it? So, and what is the probability of no disease among exposed? 40/100. So 60/40 will be the odds of disease among exposed, yes or no? And 20/80 will be odds of disease among unexposed. And the ratio of the two would be odds ratio, right? And risk ratio will be what? 60/100 divided by 20/100. That is what is the risk ratio. So that is how you will calculate. So you will use odds ratio for case control and or odds ratio for non-prospective. See, you saw 3 study designs, 4th is coming. From statistical or analysis point of view, only two ways of doing this. Do you see some similarity between cross-sectional and case control? What is the similarity? What is difference? Similarity is when you enroll the participant in your study, both outcome and exposure are there. Isn't it? Whether cross-sectional or case control, both are there. Right? And what is the similar, but what is the difference? Difference is the manner of enrollment of participants. In cross-sectional, neither the outcome nor the exposure is criteria of enrollment. Whereas in case control, participants are enrolled based on the outcome status. And you are measuring exposure, right? In cohort study and clinical trial, what is the similarity? You are starting with exposure, measuring future outcomes. That is prospective. That is similarity. What is the difference? Cohort exposure is self-selected. In intervention, exposure is being assigned by the investigator. So that's a similarity. So that is why analysis is done only in 2 ways. So odds ratio would be for non-prospective and risk ratio would be for prospective. Prospective is always fixed for future outcomes. Prospective is always fixed for future outcomes. Retrospective is always fixed for past exposure. That's all. And also the way you make table for these 4 study designs is not same. The way you make table for case control and cohort is you make in one way. And the way you make table for prospective studies in one way. And that clue you take from what they presented. They did not present that you do case control study. In case control study, you can measure multiple past exposure. In cohort study, you can, or in prospective study, you can measure multiple outcomes. Right? So that you look at papers, any prospective study, any prospective study, when they make table, exposure would be the column and row would be whatever is multiple. So in prospective studies, rows would be the outcome. In non-prospective studies, what is multiple? Past exposure. So outcome would be in the column and exposure would be, right? And you always calculate percentage column wise. If you follow these two rules and calculate the percentage, always column wise. In case control studies, what do you want to know? Prevalence of exposure among cases control. In prospective studies, what do you want to know? Outcome rate in exposure and exposure 1 versus exposure 2. Right? So that's how you make. So these, if you can get this, then rest all is just technical. So next, please. So for case control, again somebody asked how many controls I should take. Should I take one case and one control? Then you were told that no, take up to 4. Why did he say 4? Why did he say 4? Rule of thumb in case control study is that numerator should be matched. Say for example, if my factor is smoking and outcome is hypertension, if my factor is smoking and outcome is hypertension, odds ratio is 2, then roughly you need so where there will be more smokers, among cases, hypertensive, isn't it? So then you need to have to match same number of smokers in control. You have to take 2 controls per case, right? So you need two controls and 1 case. Do you ever see any risk factor having odds ratio more than 3-4? Have you ever seen any? Where are such risk factors? There are hardly. I have not seen any risk factor having. So that is why there is no point in taking more than 3-4, right? So, and this more number of controls you take also when getting cases is not easy, right? So power of that case control study, again, it depends on this kind of ratio also, right? So that is why you will say you never see any study where more than 3 controls per case. Where are the factors? If there is a factor which is more than 3-4, it will be very obvious, right? You don't see more than 2, less than 2 only you see. 2, 3, or less than 3. Okay, next. Now, so then I think these are, after that there are examples. This example, then table, if you see, go next. Here it is 407, there you get 408. You just spend some, very easily you can read this. So I'll not spend time on this. Next. Cohort study. What would be the input in cohort study? Relative risk and precision. So again, example, this is a formula, go next. This is example, read the example, 2026, there you get 2027, go to table, there is a table next, right? So, I mean, this calculation is not a problem. Then after that, it's clinical trial. After that is clinical trial. And again, I have given clinical trial example I have given for, there are 36 types of clinical trials. There are 30 minimum, not at least 36 types of clinical trials, right? And you need to do sample size calculation for each one of them, right? Your clinical trial can be parallel, can be crossover. In parallel and in crossover, your unit of randomization can be individual or cluster. So ये दो और ये दो इधर 4 हो गए, right? And in each one of them, your trial can be either superiority, non-inferiority or equivalent, right? कितने हो गए? 12 हो गए. And in each 12 of them, your outcome can be either categorical or quantitative or time to event. 36 हो गए, right? So this is minimum, and after that more variations, right? So, but there are minor changes in the sample size that you do. So anyway, all this will be, I will not tell all this. It's all going to be discussed in clinical trial. So I can see that my eyes are on the clock.
के बारे में तो एक बहुत फेमस शो भी है वो समझो ब्रदर ये देखो और फिर मुझे यानी अपने
crossover trial and all that will be explained to you, right? So I'll next tell you. So I'll prefer to take questions. You can take it, yeah. But चलिए हो गया लगभग.
Sir, can I ask you?
Please, please.
Sir, you had listed all those situations where sample size is required, so like incidence, mean and everything. What if we have to do a genetic study?
Genetic study. So again, in genetic study, see, I understand only exposure and outcome. I understand only exposure and outcome, isn't it? So in genetics, so what you state your objective, you state your primary objective. From there, I will proceed for sample size. Genetic study is type of study. So what you want to study, what you want to estimate in genetic study. So,
That
see,
question needs to be
of
asked.
course, because sample size is based on the question. In genetic study, do you want to do a descriptive genetic study? Do you want to do analytic study? Right? So do you want to estimate कि भाई जिनमें ये genetic ये उनमें क्या है?
It is usually what proportion of one disease would have some kind of a mutation.
Right, isn't it? So what is that kind of study? What is the study? Now you have heard the study design, isn't it?
Proportional, it's basically.
Is it a descriptive, isn't it?
No,
Exceptional, sir.
What would the study design? आप मुझे बताइए.
Cross-sectionally one.
So basically what you want to know, if somebody has this disease, there will be some individual who have this disease and there will be some who do not have that disease. And you want to know, is the genetic polymorphism more common among this disease as compared to that? This is what you want to know? Yes or no?
Yeah.
This is what you want to know. So would it be descriptive or analytic?
Yes, sir. In that case,
Analytic, because you're trying to compare genetic polymorphism between disease and non-disease. Yes or no?
Yes.
Isn't it? So it will be analytic study. You're comparing. That's what you are told repeatedly. The moment you compare something, it becomes analytic study.
No, sir, those are different, like where we take controls. Usually in clinical setting, we have a disease.
Which
Like
is
say-
one particular
Yeah,
phenotype.
For
Yeah.
example,
Being
steroid
evaluated
resistant
with
nephrotic syndrome.
So it's the
Steroid
prevalence.
resistant nephrotic syndrome is a category
Huh.
where some would have known mutation, proportion of patients are known to have mutations, and the proportions are known have not to have those mutations. Unknown. So what we don't know that whether in our population, what proportion of these nephrotic syndrome are having some kind of genetic mutation.
So basically you are saying nothing but the prevalence.
Prevalence.
That's what I
Nothing,
know.
nothing but the prevalence.
Design is of a prevalence.
Nothing but the prevalence. But this prevalence, and this would be a very rare thing or very common thing.
It's the disease itself is a rare disease,
Rare.
but it,
No.
around 30% of the patients of SRNS are known to have.
Okay, so this simply boils down to prevalence study. Simply boils down to prevalence study, isn't it? And when you calculate the number that you get, what would be that number? That would be the number of patients of this rare condition, isn't it? That so to get these many prevalence, these many cases, how many you have to screen to get these many? You have to work backwards. You get what I'm saying? If you're doing this in clinic, and the clinic is only for this rare disease, then you don't have to do backward calculation. But if you're doing in population, right, where prevalence is very, very rare, then you have to work backwards to screen that many to get these many rare cases.
So basically it will come out by 4 PQ by D square.
Exactly. Isn't it? There is no other way.
So sir, what would be the timeline? For example,
The-
I asked the question repeatedly, like we are getting the numbers, but how much time, is required? Because it can be a reflection of an entire, say for example, North India, but I'm not studying the whole.
No,
kind of-
again, see, the timeline depends on so many things, isn't it? Timeline depends on so many things, isn't it? Where you're studying, suppose you are studying a disease which is very rare. So maybe in a month you are getting just 5 cases, isn't it? So screen so many to get 5 cases. It's very rare condition. So rare condition, you have to screen too many participants. More you screen, more will be your, duration of study.
And so as a collaborator, we are getting the questions you have to small sample size. But we have actually, calculated the sample size based on what we are getting in that particular setup. But is it, significantly correct in a sense?
Again, I'm telling you, sample size not calculated based on what you're getting in your setup. That is your convenience, isn't it? First you calculate your sample size and then you see Then you see that in your setup, I mean, what is the kind of numbers you are getting, right? So you think of a research question, for that you calculate your sample size, then you look into your record, see, last 1 year I could get only 5 patients. I could get only 5 patients, isn't it, in my hospital? Now, then, is it feasible to do this study for you or not? It's not feasible. Modify your question, or you do a multi-site studies, right? So that's why they said first lecture was on research question. Your research question must fulfill 5 criteria. You were told finer feasibility. Feasibility from what point of view? First is number of participants, right? So you should see that are you likely to get or not. Second is feasibility from, do you have the technical expertise to do all that, right? You may not have, but can you, by collaborating, can you do that? Isn't it? So those kinds of feasibility, if you don't see the feasibility part and you start the study, you will feel frustrated. Right? So feasibility part, you modify your question or take up, or if you still want to do, then please go ahead and involve other studies, isn't it? Involve studies, or maybe you little bit expand your inclusion criteria, don't be so strict. So all those things you have to do it to make it feasible, right? So it is basically, you have to see feasibility part. Your question may be feasible. If it is not feasible, what can be done to make it feasible? Right? If it is not ethical, what can be done to make it ethical? It's not that if it is not feasible, you dump it. If it is not ethical, you dump it. Can I make it ethical or not? So those things we have to do. Yes.
Between a single center with a multi-centric, so we have number, you may actually get it done in one single center also. We can get it done in 3 centers also.
Yeah.
So how do you suggest?
Now, see, again,
when do you desire to have more than one center?
Right. See, when do you desire to have more than one center? See, again, please distinguish between multi-site studies and multi-centric studies.
Multi-site.
So both are multi-site. Both are more than one site, but there is a difference between multi-site and multi-centric study. Multi-site from the point of view of sample size. Multi-site studies, that means more than one site. Each site will have adequate number. Sample size is adequate enough for each site to draw their own conclusion. That is multi-site. And all of these sites, protocol is same. You could compare your results because protocol is exactly same. And each site has adequate power, adequate precision. Sample size is adequate for each site. That is multi-site study. Multi-centric study is single study. And the number that you calculate is shared between multiple centers, right? So none of the center have adequate number to draw their own conclusion. You understand? So that is multi-centric, but both are more than one center, right? So when you do multi-centric studies you do, there are advantages of multi-centric study, there are disadvantages. Advantage is that in less time, you get more, you get what you want to get. You are able to enroll participants. Disadvantage is apples and oranges. 5 centers, 5 people are doing in 5 different ways, and you are combining apples and oranges, right? So there are more threats. What is the other advantage? Better generalizability, isn't it? Better generalizability. So in multi-centric studies, your hypothesis is A better than B regardless of the center, isn't it? So those are kind of other things.
Example of correlation and agreement.
Yeah, correlation is between, let's say, is there any correlation between BMI and blood sugar? Is there any correlation between BMI and blood sugar? Agreement would be, is there any agreement between 2 methods of measuring weight? Or 2 methods of measuring blood sugar?
Sir, you had mentioned about what to be set in rows and what to be set in columns in certain studies. Could you please repeat it, sir, please?
Yes, though it was not, but somehow it just, I said, I was not supposed to say this. See, you have 4 study designs: cross-sectional, case control, cohort, and clinical trial, which will come. But now you know what is clinical trial, isn't it? having understood cohort, you know what is clinical trial, only difference is intervention. So two studies are prospective, isn't it? Two studies are prospective. That means in two studies, you are measuring future outcomes, cohort and clinical trial. And other two studies are retrospective. That means when you enroll the participant, both outcome and exposure are there. Right? When you enroll, then both are there. So in prospective, your column has to be exposure because you are measuring multiple outcomes. You can measure multiple outcomes. In non-prospective, your column has to be outcome because you can measure multiple past exposures. So that's what I said. And once you do this, and then you calculate percentage column wise. Your calculation should be what you did not know. Your calculation should be what you did not know when you planned your study. So in prospective study, what you did not know, you did not know the outcome rate in exposed and unexposed. So you calculate that. In non-prospective, what you did not know, you did not know prevalence of exposure in cases, and so calculate that. Right? In cross-sectional study, what you did not know, you did not know anything. You did not know the outcome rate, so calculate that. You did not know what you, isn't it? So secondary objective in cross-sectional is like primary objective of case control. But here only to generate hypothesis. So
I have a question, sir. Sir, actually, I'm validating one assay, sir, for which we are targeting 3 pathogens. If the individual prevalence rate of 3 pathogens is different, so how should we calculate the sample size, sir?
Suppose you have three pathogens. Now the
Yes, sir.
expected is not the same, right?
Yeah, I'm doing a multiplex assay for these three pathogens.
Whatever. So that is method of sampling. Sorry, I did not touch the sampling part. So sampling is different. So you have 3 outcomes, isn't it?
Yes, sir.
3
Yes,
outcomes. Let's say I am also doing the same kind of study to know what is the prevalence of smoking, what is the prevalence of hypertension, what is the prevalence of stroke. Like you have 3 pathogens, I have 3 these, right? Now all these 3 are not equally prevalent. So which one you think would be less common or rarer?
Yes.
Smoking or hypertension or stroke?
Stroke.
Cat shoulder. Rarer the outcome, larger will be the sample size. So either I do all the 3 calculations or forget about 3, I'll catch hold of the rarest one and do the calculation. Whatever number I get would be more than adequate for other 2 outcomes, which are more common than this.
Okay. Okay. Yes, sir.
Yes. So, still people are having questions, but in the interest of time, actually, we are now delaying by 1 session already. So we are having next session with Dr. Partha, and we are very thankful to you for this.
Sorry, I just skipped. Example, these slides can be shared with them.
Yes, sir, and we are having one more session with you tomorrow. So sure.
Sir, how to determine sample size for screening study?
Kindly put your question in chat box. We will.
How to
use samples? How to calculate sample size for screening? Like suppose you want to screen population for cancer. So in that case.
So just very quickly, just 30 seconds. See, screening or confirmatory both are diagnostic test studies, right? Isn't it? Yes, and screening test should have higher sensitivity, isn't it? So use the same. The method of calculation is exactly same.
As per diagnostic.